Hi guys, this is Miss Wesley here, and we are ready to go for Unit 2. So Unit 2 is all about angles. Our unit name is Unknown Angles, and Skill 1 talks about two very specific shapes, triangles and quadrilaterals. So the first thing you want to do is up at the top of your paper here, you'll notice I jotted down our essential question for today. So our question is, what do all the interior angles in a triangle and a quadrilateral add up to? So in the top of your Cornell notes here, take a minute, copy that down, and by the end of this video, hopefully you should be able to answer that question. So if you need to pause it right now to go ahead and copy your essential question down, feel free to do that. But we're going to jump right in here and talk about the different angles that you're going to see in triangles and quadrilaterals. So the first example says, given the diagram below, the measure of angle BDA is 95 degrees, BCD is 64 degrees, and ABC is 90 degrees. So what I'm going to do is, if you take a look at the first line here, BDA is 95 degrees. You might be asking yourself, well, where is that 95 going to go? How am I going to figure out which angle is actually 95 degrees? And it all goes back to the letters. So it says BDA. So with your pen or your pencil, you're simply going to follow that outline there. B to D to A. So this angle right here, that angle right there, that's going to be our 95 degrees, because if you follow the outline B to D to A, that D is right in the middle between B and A there, so that's where we're going to label 95 degrees. Let's see if I can get my pen working here. 95 degrees, make that a 9. Come on, there we go. 95 degrees. Hopefully my writing will get better after a few. If we look at the next angle, so this says angle BCD is 64. So just like I did before, I'm going to follow the order of those letters. B to C to D. So this angle over here in the right-hand corner is going to be 64 degrees. And the last thing it says is that angle ABC is 90. And if you take a look at that, A to B to C, well, they already have that little red square in there, and that's a key that those squares always are going to represent 90 degrees. So that one's already kind of labeled for us. So if we look at what the question's actually asking us to do here, it says determine the measure of angle BAD and explain your response. So we're going to first figure out where is angle BAD. So if I go over here and again follow the outline, B to A to D. I'll do it one more time. B to A to D. I'm in the orange there. We're looking for this angle over here in the corner. So the first thing that we need to know, and this is really important that you write down, is that all angles in a triangle add to 180 degrees. And again, I did some abbreviations here, angle symbol, and I did a triangle symbol. Any symbols that you see me or Miss Griffin write, feel free to write. We're never going to abbreviate something that you can't do on your exam or a test. So knowing that piece of information here, that all angles in the triangle have to add to 180 degrees, this orange angle over here to the left, you might be saying, well, that's in the left triangle, triangle BAD, but it's also in the big triangle. So if we look at this triangle as a whole, we already know two of the three angles. I know this angle up here on the top was 90 degrees, and I know the angle in the bottom right-hand corner was 64 degrees, so that means the only angle I'm currently missing is the angle I'm looking for, angle A. So if we know all the angles in a triangle have to add to 180 degrees, we can simply, you can make a little equation, or you could just subtract and say, well, 180 minus the 90 minus the 64. So if you go ahead, pause, plug that into your calculator, we're going to figure out that the measure of angle BAD is 26 degrees. All right. So a little sentence we could write would be to say the measure of angle BAD equals 26 degrees because, and again it said explain, so we have to explain our reasoning. Angles in a triangle add to 180 degrees. Okay. So that's our first answer. I can go ahead and write in, I'm going to write in that 26 so I don't forget that when I'm looking later. So right over here, this angle was 26. I think I gotta get a new pen. 26 degrees. Okay. So the next part here says explain why the measure of angle CBD is 31. So we first got to figure out where is that angle once again. All right. So I'm going to follow the letters. C to B to D. So I'm looking for this top little angle up here. And you might see that red box and be like, well, it's 90. But it's not, because ABC, this entire angle B was 90. We just want to know what's the right-hand side of that going to be. So there's two ways you could look at it. We could focus on this triangle over here on the right. All right, triangle BCD would be called. I already know one of the angles is 64 degrees. I'm looking for this angle up here at the top. So if I was able to figure out what this angle down here was, then I could do the same thing I just did up above. Add up those two angles and subtract them from 180. We can actually figure out what this angle right here is though. All right. If you notice, we said this angle to the left here was 95 degrees. And something you're going to need to know is that angles on a straight line also add to 180 degrees. So if the left side of D, or we said angle BDA was 95, we can go ahead and figure out what BDC is. So we could make a little equation that says the measure of angle BDA, that was my angle on the left that we already know is 95, plus the measure of angle BDC, that's the one that we're going to look for in the meantime. Those have to add up to 180 since angles on a straight line add to 180. So just like angles in a triangle add to 180, angles in a straight line also add to 180. So if we go ahead and do the little bit of math here, we know that 180 is what those two angles have to add up to, minus the 95 that was on the left. I really need to get a new pen. Come on, 95. All right, there we go. And if we subtract those, we're going to figure out that the angle on the right there is 85 degrees. So that's not our answer though, because it said prove why CBD is 31. But this angle over here where I had that orange arrow is 81 degrees. All right. So now that I know that, we can go ahead and figure out what angle CBD is. Even though the question already told us it's 31, we actually have to prove it to get there. So we can write another sentence here. All right. We know that angles in a triangle add to 180. So if we go ahead and do a little bit of math here, we now have 180, because it's a triangle, minus the 81, which we just figured out because that's one of the angles in our triangle, minus the 64, because that's the other angle in our triangle. Yikes, my pen's really bad. And if we subtract those, we're going to end up getting 31, which is what the problem told us we should get. If for some reason you end up getting a number different than 31, please go back and check your math. Maybe you wrote down 86 instead of 85 from up above. But the big idea here for this first page of notes is that angles in a triangle always add to 180 degrees. And the other thing you want to be aware of is anytime you see the word explain, you need to have a sentence to back up your answer. And if it's a more than one step problem like we had here, you better have a sentence for the first reasoning or thing that you came up with, and then a second sentence to summarize what you actually found. All right, so I'm on the second example here. Again, if anything you missed in the first example, feel free to pause, go back. So we're now going to look at this picture that says, given the diagram below, determine the values of x, y, and z. So we have this picture, we know three angles, we have 82, we have 67, we have 104 degrees, but we also have these three letters, x, y, and z, that we want to figure out what they all are. And there's a lot of ways you could go about this. You could start with any letter, really, it wouldn't matter too much. But I'm going to keep going with what we talked about in the last example. So for instance, I'm going to focus right now up here on y. We know this angle here is 67 degrees, and y is what we would call adjacent to it. It's right next to it. For instance, my classroom, I always like to say, is adjacent to Mr. Endreis's room. We're right next door to each other. So these angles would be considered angles on a line because if you take y and 67, you'll see that they share that straight line there. So thinking about what we said in the last example, angles in a straight line have to add to 180 degrees. So to find y, let's see how I want to write this here. We know that 67 plus y has to give us 180. Right? So if we subtract 67 over from both sides, we're going to end up getting 113. So y is 113. I'm trying to write it. There we go. 13 degrees. So I'll go ahead and box that. That's one of our answers. And if you look at the picture, you might be saying, well, there's actually another angle on a straight line. And you're right, down over here. 82 and z would also be considered what we call supplementary, meaning that they add up to 180. So we can do a very similar setup here. This time it's just going to say 82 plus z equals 180. So subtract the 82 over. And we will see that z equals, and again, if you are someone that wants to do this math on your own, pause the video, break out a calculator, and just check your numbers with mine. We're going to get z equals 98 degrees. So I'll go ahead and write that one in. 98 degrees. And just for your notes, if you're someone that wants to reference them back, hopefully, which we will, these two ideas right here, those both came from angles. That should say angles on a straight line equal 180 degrees. So we have two of the letters figured out, but we still have to figure out what x is. So if you look at 104 over there to the right, we haven't really used that angle too much yet in this problem at all, but there's something that you're going to use the rest of the year here in geometry, and it's what's known as vertical angles. Vertical angles are angles that are opposites of each other, so notice these are not adjacent, and they occur when two straight lines intersect. And what's special about vertical angles is that they're congruent, and if you think back, congruent means equal. So since this angle down here is 104, that means this angle over here is also going to be 104 degrees. So if you wanted to write a little side note in there from what we just talked about, these are called vertical angles. And they are congruent. So bottom right hand corner was 104, so this angle right over here was also going to be 104. And now if we go back and look at z, which we just figured out was 98 degrees, I can say that since z was 98 degrees, this angle over here will also be 98 degrees because those two are also vertical angles. There's one letter we haven't found yet, and that's x. So x doesn't have another angle next to it, so we can't subtract it from 180. We don't know its vertical angle. There's nothing in that spot right now. But what you want to think about is look at this shape formed between these lines here. We have a four-sided shape. Four-sided shapes are called quadrilaterals. It's not a rectangle, it's not a square, but all quadrilaterals add up to the same number in terms of their angles every single time. No matter what kind of four-sided shape you have, they always add up to the same thing. It's not 180, but this time it's 360. So in order to find x, we actually have 3 out of the 4 angles already. We know this angle over here is 67. We know this angle over here is 104. We just said that this angle is 98. So now we have left is we have to figure out what x is. So like we made an equation for the previous 2 variables, we can do the same thing for this one. So we know that x plus 98 plus 104 plus 67 equals 360. And again, I'm using 360 instead of 180 because this is a four-sided shape. It's a quadrilateral. Triangles add to 180. Quadrilaterals will always add to 360. So if we go ahead and simplify our equation here, x plus, I'm just going to add up the 98, the 104, and the 67. Those will give me 269 equals 360. Subtract the 269 over. And we will determine that x comes out to be 91 degrees. So each of those variables there had a little different story behind them, how we actually went about and found x. But the 2 big takeaways so far, that angles in a triangle add to 180 and angles in a quadrilateral add to 360. And since we didn't jot that down anywhere yet, off to the side here, I'm just going to go back and add in that angles in a quadrilateral, I'm going to abbreviate that with quad, equal 360 degrees. So the last thing we have here is to explain how you determine the value of x. And even though we have all our work back up here, it is very common in geometry and even on the Regents exams for them to ask you to explain. So you want to make sure you're using complete sentences here with all the information that you did, just in essentially almost a small paragraph form. And to save you from trying to decipher my messy handwriting here, I kind of typed our little paragraph up that we would want to write. So the big ideas here were that we knew vertical angles are congruent. We also knew that angles in a straight line add up to 180. So knowing that, we were able to find the interior angles of the quadrilateral. That was the 67, the 104, and the 98. Then from there, we knew that angles in a quadrilateral have to add to 360. So we were left to do the subtraction. 360 minus the 67 minus 98 minus 104 left us with a final answer of 91 degrees for x. So when you go about explaining your work here, obviously your phrases might be slightly different than Ms. Griffin's and myself, but you would need the same big ideas. So big idea being vertical angles were congruent. You use the fact that angles on a straight line add to 180 to find the missing interior angles. And the third big piece was that angles in a quadrilateral add to 360. So 2 ideas, angles in a triangle add to 180, quadrilateral add to 360. I know this was a long video. I apologize. Hopefully my handwriting will get better next time. So go ahead and try those practice problems, take your CFU, and then once you're all set, move on to skill 2.2.